Hi guys, welcome back to the channel. Today we'll be diving into a few more Linux commands. Some of these commands are different and are not commonly used, but they are worth discussing. In this session we will be talking about commands such as nl, shuffle command and more. So let's get started. I am located within Windows subsystem for Linux, and folder is my current working directory. So yeah, the nl command basically is a command which is used for effective means of getting numbering of the lines in a file. Let's say if you have a file and let's say you want to format the file with numbered uh, text appearing next to each of the lines for ease of readability or processing. Under that scenario, you will basically be setting up the nl command. um, uh, for the purposes of this, I will basically create a new file called filename.txt, and let's just write typical data. This is line 1, this is line 2, this is line 3, this is line 4. Let's do that. Quit. So typical structure for the nl command basically looks like this, where we basically type nl followed by the file name. So here we basically write nl followed by filename.txt and hit enter. You can see that by default we basically get a numbered text data attached prefixed before the actual lines of the file, which is not an information that you would usually find if you use the cat command in order to get the output. With the nl command, there are also other options and tags which can be used to tailor its behavior. Let's say we would like to set blank line behavior. For that, you write nl -b followed by let's just write a file name.txt. For the purpose of this, once you have written that, here by default nl basically would skip blank lines, but with -b option you can basically decide how a blank line is handled. In this case, basically all numbers will be appearing against the lines, including the blank ones. So for that I will have to change the file. Let's say we go into insert mode. Let's just randomly enter some blank lines, and when we hit nl-b a file.txt, you can see that the numbers basically appear against even the blank lines as well. This is because we have specified a, which is a tag for including also the blank ones here, where all the blank lines are also considered as a line. We can also set a separator between the line numbers and the text. For that, let's say you want to control what separates the line number from the text. For that, we can basically mention or specify a new tag or -s called -s, and let's say we basically separate the lines by colon followed by the name of the file. Once you hit enter, you can see that now there is a separation between the line as well as the number, which appears prefixed against each of these entries and records. So here we can see the colon appearing here. Similarly, we can basically change this to any symbol, let's say plus symbol. Once you hit that, you can see that the same has been done as well. Another way to showcase the difference between -b and s is that the numerical values do not appear against the blank lines and they are ignored. Another way to format this structure would be the use of control numbering format. For that, you basically type in -n. With -n, you can basically change the formatting of the line numbers. So we will write nl -n followed by the line followed by the name of the text file. Once you hit enter, you can basically see the numbers are basically prefixed at the far right of the entries. So here we basically have mentioned left alignment for the line numbers, but other options are also available like RZ, which can be used to specify right alignment with zero padding. For that we can basically change ln to RZ. Once hit enter, you can see that our padding has been inserted against each of the record entries before the prefix numerical values for each of the lines, and these values basically have been filled in with zeros. We can also set up the width of the line number with the help of, let's say, -w, which is another tag with nl. For that we will basically type something nl -w followed by number 5, any arbitrary number. Here we are basically specifying the number for the sake of a character width. So here it could be any character width. In our case, this is the number that I choose, and once I hit enter, you can see that not much of a difference, but yeah, you can basically see a level of let's just try to execute one of the previous commands to make this a little bit more clear. We'll just go back to the previous -b and let's just execute this. Yeah, so you can see that there is a slight variation with a little bit of padding appearing before and after the prefix text file, text entries. So you can see this character spacing is not that widely visible, but it is inserted. So yeah, this will basically make sure that the line numbers are basically at a distance of 5 character width. And yeah, so from a practical standpoint, NL in real world scenarios basically come into play whenever we are working on preparing files for processing or review. Let's say we are working with large configuration of files or code files, such that we add a line number to help us with troubleshooting or reviewing or editing purposes. You would basically use the NL for that practical case, whereby which you can also format reports. Let's say in order to generate reports, you would rather have a read easy method. For that you would like to serialize the entries. So at that point you basically use NL, and you can quickly add a level of clarity to your file. Another basic use cases can be with regards to, let's say, an advanced version of NL would be -b and p, which I haven't shown, but let's just showcase that as well. So let's say we are numbering only non-blank lines, and let's say the serial numbers need to be appearing against them. For that you would follow up NL-b followed by t with the name of the file. Here -bt option basically is used to basically specify that the numbers have to only appear against non-blank lines. So the numbers have, only are prefixed against the content, which is the text. We can also add custom line numbering. Let's say we would like to start from a specific value, let's say 10. For that you basically need to specify the tag -v followed by a numerical value. Let's say we would like our serial numbers to begin with the number 10 instead of 1, which is by default. We will basically execute this, so you can see that the serial numbers start with 10 followed up till 13. So yeah, this is a useful way to use up NL command. It is pretty incredible how you can use these commands for working with files. It enhances readability as well as debugging, especially whenever we are working with large files such as log files, which require certain structure. Yeah, so let's move on to the next command. The next command that I will be diving into is the shuf command. Shuf command is short for shuffle. This command basically randomly shuffles lines of a file or an input. Let's say you have random lines which need to be shuffled, so that's basically what it does. It's extremely useful whenever you need to generate random samples. Let's say we are working with machine learning and you would like to generate random sample sets for your training, testing and validation. 80-20 rule which comes into play, and you have a large data set. You can also use this in that scenario. So yeah, let's just create a new names.txt file and let's just randomly insert some text files. Let's just write, okay, text data like names, which is Alice. Let's just write Bob. Let's just, yeah, let's do something like this. Once done, we basically write and quit. So yeah, here we can basically read the contents of our file. It appears somewhat like this, and let's say we can basically shuffle this data like a deck of cards. You basically write shuf followed by the text file of your interest. Once you hit enter, you can see that the order, which basically started with John and ended with Dave, has been shuffled, for the lack of a better term, and you can see the names are jumbled with no specific order uh, in to be in consideration. There are also certain options which are available, and this is just the basic syntactical structure of the shuf command. Let's go into some of these more commonly used options which can allow us to modify the behavior. Let's say the -n option can be utilized here in the same structure as before. -n followed by a numerical value and followed by the name of the file. The -n value basically is an option that allows us to specify how many random lines you would like to display in our with respect to the input file. Let's say if you want to display, okay, in this case 5 won't suffice because the number of lines are 5 itself. Let's say if you write something like 3, it will only display 3 random lines from the text file. So accordingly you can see that the 3 names have been showcased. We can also use an explicit input instead of passing a random, let's say instead of passing a random file, we can basically do the same with regards to certain entries. Like let's just give some random entries in along with a concatenation with -e. This would allow you to explicitly enter text into the shuf command, and this text data that we are passing would be shuffled and you would see the order change. Yeah, let's say if you wanna basically store this shuffled output into some file, we can basically use the -o option to basically store this output into a new file. So we will write something like shuffle names .txt. once you hit enter, and let's just print out the contents of the file, you will see that the contents have been rearranged, and yeah, that basically that output which would typically be displayed onto the terminal has been stored into this secondary file. We can also use a random seed. Random seeds basically change the way the shuffling occurs, so it basically reduces the chance of reproducibility, or in some cases if you want to shuffle it in a predictable manner, you can basically just mention that specific seed value as well. So seeds basically are, basically change the way the output comes. So to explain this, I would like to just let's say it's a pseudo random number. It basically produces the same sequence of numbers. Let's say if you use a different pseudo random number, the number generator would produce different set of results. It usually comes into play with cryptography or certain algorithms, but yeah, that's the way it is. So basically it would just change the way the randomness occurs. So yeah, we can basically just give this random 1 2 3 4 5 number followed by the names.txt. Once you hit enter, let's me. Okay, I'm not sure why that happened. 1, 2, 3, 4, 5. Okay, let me just redo this again. Okay, I don't know what happened. Let's just wait a moment. Let's just wait. The next command that we'll be diving into is the stat command. The stat command is used to display the detailed status information associated with files as well as directories. So it showcases metadata such as permissions, size, timestamps and more. So for the purpose of this, if you write stat followed by the name of your file, and once you hit enter, you would come up with some extra detailed information like this, such as the day it was created, the number of block size it's occupying, number of links, the type of computer on which it has been created, the inode index node value, so this the physical memory location where this data is being stored, and the latest data regards to the access having taken place, latest modification or any other changes, and as I have previously mentioned, the date of creation. So yeah, such interesting statistical details can also be showcased with regards to within Linux with the help of the stat command. As you have previously seen, the basic structure or syntax basically looks like stat followed by the name of the file, and there are also other options which are available, which allows us to customize the output. For that, you basically follow up stat -c followed by let's say we would like to look into the name, size and the latest date of modification, i.e. the time of latest modification. So you would basically follow up with %n, %s and %y followed by the name of the file. And once you hit enter, you can see that here we are able to retrieve the name of the file, the size, the number of kilobytes it occupies on the memory, as well as the latest date of modification along with the time. So yeah, these visuals allow you to customize your output in a efficient way. You can also let's say use the -f option to basically display information of the file system. So let's say we would like to basically use something like stat -f followed by the name of the file. You can see that the data now, yeah, the output is pretty much a little bit different, but it is just a formatted form, I can say, as to mention, like. But yeah, you can simply just use stat followed by the name of the file. So yeah, there are other commands as well. Another command that we can dive into is the pipe view command or the pv command. The pv command or pipe view command basically is a tool to monitor progress of the data that has been transferred from let's say through a pipeline, whether it is copying, compressing or performing any other operation. PV basically lets you generate a progress bar and basically lets you give out an estimated time requirement throughout the process. Let's say let's say we can try to compress a file into gzip, and we would like to see let's say some information associated with the amount of time it takes to compress that specific file. So the command structure would look something like this, followed by let's just write names.txt.gz. Once you hit enter, you can see that we basically have compressed this particular command, sorry, this text file into a .gz file, and basically here in the output you basically get a loading bar which specifies the amount of progress it has taken to perform this task of compressing information. So basic structure would look something like this: pb followed by the options followed by the source. Let's say this could be any source file. Just type source followed by command, and yeah, so that's how the process would look like. Yeah, let's just say we have a large txt file, and let's, instead of loading bar, we would like to see a let's say loading progress bar. For that we basically we can perform the same command as before, but instead of this we basically mention -p before the name of the last text file, and once you hit enter, yeah, here you basically see the same progress bar as before minus the other crucial data. But yeah, this is how Linux uh, basically segregates across progress bars as well as uh, simple loading bar. Yeah, we can also use the -e to basically also showcase the estimated time remaining to perform a particular operation. We would basically write the same command as before. Let's just change the routine a little bit up, so we can basically write this somewhat like this. Let's just write something like this, and just let's say we were trying to make a tar file. Let's write something like this. Let's just store into an archive file. Yeah, sorry, my spelling is a little bit off. And write something like this, and once you hit enter, okay, yeah, sorry, I have to the tar yeah. Yeah, here it's preventing me from creating an empty archive. Let me just see the contents of file name.txt. I suppose this is not big enough. I suppose let me just change this to some other file. Let's just shuffle names.txt. Let's hit enter. Do we have that file pre-existing? Let me just see. Yeah, I'm not sure what the issue is, but when I use the same command, the same example with another command structure like gz, once I hit enter, you won't see that output, because with this specific command we are basically showcasing the amount of estimated time for processing this specific operation, but in this case this process happens very quickly, and therefore the ETA associated with such a process is too quick to be shown, and I suppose that's why I'm getting blank. But yeah, I hope if you are getting some different result, I do not know, that might be better. I do not know if this is just a problem with WSL, but this is what I am getting. Yeah, you can also try some other structural formats as well with the help of -a, which would basically show the average speed of compression for this process. I'm not sure why this is not working for me. -e, I'm not sure, but -a indeed works, which is an anomaly. As well as you can also use yeah, this for many other aspects for compression of files. Another practical scenario would basically be monitoring large file transfers, or compressing large files, or creating disk backups. You can basically use pb command to create a custom progress bar. You can also use that same command for simulating progress reports, basically creating, yeah, that you can basically set up a progress bar or a loading bar. um, yeah. So yeah, to conclude, pv command is a powerful tool. You can basically track many changes throughout your process while you're working with data, especially in pipelines. It makes it much more transparent and manageable. And yeah, I hope you learned something today, and I will see you in the next one. Bye.